Hi everyone. Uh, I will share my screen and we will start now. Uh, okay. Okay. So today we will see about a new topic called block report. So I will explain why this procedure is important. Before going to that topic, I will introduce one website called clinicaltrial.gov. I don't know how many people would have heard about this website. So generally, if any clinical trial or any pharma company conducted any clinical trial in US, that pharma company has to post the clinical trial in this website. So all the trial happened in US has to be disclosed in this website. Okay, so you can see the all cancer trial or HIV trial, any kind of clinical trial results you can see in this website, clinicaltrial.gov. Okay, I will tell why I am showing this website. Okay, so you can filter down by so many fields. If you want to, if you want to see phase three studies, then you can filter down phase three studies. And if you want to see interventional studies, you can filter down. And then I want to see all the clinical trial results. Okay. Okay, so I'm selecting one trial, clinical trial here. This clinical trial is some cardiovascular disease trial. Okay. Okay, I think Mexidol, this trial is about Mexidol. I think it is for hypertension or some cardiovascular disease. So they are checking the safety and efficacy. So what pharma company has to do is once they have posted, they have to disclose the results. Okay. They have to disclose how many people started the clinical trial, how many people completed the clinical trial. So we have the two arm group here, two population. One population is taking the main treatment, Mexidol. Another group of people, 159 subjects, taking the control. Okay, so there are two set of arm group, two set of population. One population, 159 subjects receiving the Mexidol. Another 159 subjects receiving the placebo. Okay, so 159 subjects started the clinical trial for main group. 159 subjects taking the placebo group started the trial. Out of 159, 159, 57 subjects completed the clinical trial. Okay, in the main treatment. In control, 159 subjects started the trial and 155 completed. Two not completed the trial, four not completed in placebo group. So this is called disposition table. Okay. So this is one set of table. And so what pharma company do is they will have the source data in Excel sheet or database. They have to generate this tables. Okay, for so many purposes they have to generate this disposition table. And then also pharma company in this website they have to disclose this baseline characteristics for each arm group. What is the population in adult? What is the population in older adult population? So there are 55 participants who are greater than 65 years old. Okay, and then there are 60 older adult population in placebo group. Okay, so we have to give the data about age, we have to give data about gender, how many male in placebo group, how many male in the main group. So we have to disclose the detail about age, sex, and race. Okay, so these are all the tables the pharma company has to generate from the source table. Yes. So after they generate, they will post it. They will send it to regulatory authority, or they will post it in this website. Okay, and there is one more table called adverse event. Okay, the adverse event table means so we will have two arm group, main treatment and placebo group. In each arm group, how many people got high blood pressure? How many people got some palpitation, tachycardia? So if they got any adverse events, it has to be listed down in this adverse event table. Okay. So these are all some main table: adverse event table, disposition table, baseline characteristics table. Pharma company has to generate. Who will generate? Statistical programmers or SAS programmer will generate this table. Okay. So they will have the source data in Excel file. For example, let me show an example. Okay. So they will have the source data in Excel file or SAS data set. So this is just a dummy data. Okay, this is not a real data. This is just a dummy simulated data. Okay. Here I have a source data. Patient one, he is in the main group. He has taken the main treatment, and his gender is male. And then his BMI is 27.3. Okay, so we have the data about baseline and what treatment he has taken. Okay, so from that, what we can do is we can generate the this summary table: how many male in the first group, how many female in the placebo group. So we can create a summary table from this source table. So this is called source table, where we will have data for each patient. This is just a dummy data or simulated data. Okay. So in clinical trial, pharma company will have this source data. From this, they will create this summary table. How they create? They use a SAS code. What SAS code they use? They use so many things. For example, they use proc report. Okay, so proc report is the procedure. It can be used to generate this kind of tables. Okay, so we have a source data now. We are going to create some baseline table, disposition table, and adverse event table from the source data. Okay, so the how we are going to generate this kind of table is we are going to use the procedure name called report, proc report. So in clinical trial, pharma company use this procedure mostly to generate the baseline adverse event tables and all. Okay. Okay, so proc report, the syntax is after proc, give the keyword report and then data, and then use the keyword call, give the input data. Our source data is tutorial hyphen sub. So give the input data set, and then you list down what are all the columns you are going to use. So, okay, so in our data, we have patient ID, sex, and BMI. Okay. So we are going to use this call variable name in the statement called column. You have to mention all the variable names. Okay. And then there is one name called define. Okay. So define means how to define generally means how to use and display the columns. Okay. So we have four different columns now: patient ID, arm, sex. You can use the define statement to modify the structure of the table, or you can rename the column, or you can do any analysis using this statement. Okay. So using define, you can either change the structure of the table, or you can rename the variable, or you can do some analysis with this data. Okay. So first, what we are going to do is we are going to rename this variable. Uh, we have the first column name as patient ID, right? So after define, give that column name patient ID. After that, put a slash and then use a display option. After that, how you want to display this patient ID? I'm going to rename this patient ID to patient. Okay. So using this display option, you can rename the variable. Similarly, the second arm group is arm. We are going to keep the same arm. If you want to change, you can tell it as arm group. Okay, instead of that. What is the treatment they are receiving? Sex we are keeping same. If you want to change, you can change that also. And BMI values, instead of BMI, I'm putting BMI. Okay. So now using this define option, we are renaming the variables. Okay. So see here, our variable names got changed. The patient ID to patient, arm to arm group, sex to gender, BMI to BMI. So using define, first mention the define and then column name and then slash, use the option called display. After that, how the variable need to display. So this is the first example. After that, we are going to group the subjects. Okay. So in our data, we have something called arm group. Okay. There may be 10 participants receive the main treatment, 10 participants receive the placebo treatment. Okay. I think, yeah. Okay, there are totally 12 subjects. 50 percentage of participants receive the main treatment. Remaining subjects receive the placebo treatment. Okay. Now we are going to group the subjects by treatment. Okay. So first, proc report data and then give input data set name. Now D means what is that is if you don't use now D, that is also not a issue. Now D means you will see the nice interface. You will see the output display will be very interactive and very nice. If you don't use this now D, the report will not be interactive, or the it will be looks little weirder than normal way. But if you use now D, the output will be looking in a very good format. So always use this option now D, and then column you whatever column you want to display, you want to use in analysis or table, mention that column name here. And then first arm, I'm going to group the data by arm group. So my first column will be arm group. Okay. And then remaining same, patient ID, sex, BMI. I'm just keep changing the variable here. Okay. And then what I'm going to do is, if you run, only one thing we did is we are going to group the subjects by arm group. Okay. So here, if you see the participant who received the main treatment, they are coming in the order. Okay, so first the participants who got the main treatment, they are displaying here. Patient ID 1, he received the main treatment. Patient ID 3, he received the main treatment. Now the data set is grouped by the arm group. Okay, main and placebo. So if you want to group by arm, you can do that. Okay. Otherwise, if you want to, for example, if you want to group the data by sex, you can do that also. Gender. So this will group the data by male and female. So here you can see the subjects are grouped by female and male. Okay, so if you want to group the data, use the option called group. Okay, this is one thing. And apart from that, if you want to do analysis, some analysis, what is the average BMI for group A, and what is the average? Let me go to the source data. In my data, I have patient ID arm group, right? And there is one value called BMI. I want to see what is the average BMI for treatment main and what is the average BMI for placebo. Okay. If you want to do some analysis, in proc report itself, there is a way. Okay. So in proc report, give data equal to input data set and now the and then in column, you mention all the variables you want to do for analysis, patient ID, arm, sex, BMI. And then I'm keeping the patient ID. Sorry, this is okay. So we are going to keep only two variable. One is arm group, treatment group, whether main or placebo, and then BMI. Only these two variables we are keeping. And then since we are grouping the data by arm, main and placebo, use the option called group. Okay. And then here you have to mention the variable name. After that, for BMI also, you define the BMI variable. After that, we are going to do analysis, right? So use the option called analysis. And then what is the analysis you want to do? If you want to do mean, you mention mean. If you want to perform median, you perform median. Or if you want to do mode, you can do mode. Okay. Since we are doing mean, okay. I want to see what is the mean. Okay. So what it will do, it will display the mean value, average value of BMI for treatment main and average value for placebo. So here if you see the BMI is higher in placebo and BMI is comparatively lower in the main treatment. Okay, maybe after taking the main treatment, the obesity would have decreased or something. But this is a dummy data for explanation. Okay. So using this analysis option, you can do mean, median. You can do median also. Median also, the average median is 23 point, BMI median is 23.1 for main treatment and 27 for placebo. Okay. So using this analysis option, you can do mean or median. Okay. So what we are going to do is we are in our data we have sex and norm, gender and norm, right? After that we are going to one variable called count flag. Okay, count flag means how many subjects are there. Let me run this code up. Okay, so I want to see one variable. Okay, a new variable. We are going to create new variable. Okay, in that new variable, I want to see how many male is there and how many females are there in the main treatment and placebo. Okay. So in main, how many female subjects are there? In main, how many male subjects are there? In placebo, how many female subjects are there? In placebo group, how many male subjects are there? Okay. If you want to see like that, first you define the sex. Okay. So if you mention sex, the first column will be the gender sex. Okay. And then The second one, if you put arm, if you put it across, if you use the across option means the treatment variable it will be in the instead of so here if you see, okay, let me explain it in a very simple way. Okay. So you people would have understand between vertical and this one, right? So vertical means it is like a column, okay? It is a straight line. Horizontal, okay. So if you know the difference between horizontal and vertical, okay, please understand what is vertical and horizontal. Okay. In SAS, when you are using across, your data will be in the horizontal way. Okay. When you are using across, you are using the ARM group, then the data will be in the horizontal format. Okay, so the main and placebo will come in the horizontal way. But if you don't use anything, if you don't use across, then the data will be in a vertical format. Okay, female and male. See, the female and male, it is coming vertical, right? So if you don't use across, the data will be in a vertical format, female and female. But if you use across, the data will come in a vertical way. Okay, the arm group, main and placebo. So now our gender, it is in the vertical format and arm group, it is in the horizontal format. Okay. Now, if you want the data in a horizontal format, you have to use the option called across. Okay. So, so because I will explain why we are doing this. Because I have shown one example, right? CT.gov example. So in CT.gov example, if you see, so in the CT.gov example here, if you see ARM group, it is in the horizontal format. Okay. See here, the arm group will be in the horizontal format and the gender, it is in the vertical format. Okay. So if you need to do this data, then your arm group, you have to mention the keyword called across. Okay. So if you mention across, your treatment group will be in the horizontal format. And then count flag means that inside it will create one variable count. Okay, it will tell how many subjects in female and how many subjects male and how many subjects in the placebo group as well. Okay. uh, so using this define and define group across, we can create the data like this. Okay, treatment and gender. How many participants are in the female and how many participants are in male by treatment group. Okay. Okay, now in CT.gov there is one more thing called average age. What is the mean age also there? And what is the average age for main group? What is the average age for placebo group? In this study, the average age is 60.08 for main treatment. For placebo, average age is 60.73. In bracket, they have given a standard deviation value. Okay. So in CT.gov, we also create a mean for age, or we also create average value of BMI also. So instead of age, we are going to do what is the average BMI value. Okay. So whatever we did previously, we are across, we are using arm group. Okay. So our data treatment will come in horizontally and then gender will come vertically. Okay. And then it will create count also. Apart from that, it will create one column called BMI. Okay. So additionally, it will create one column called average BMI, the third column, and it will tell what is the average BMI value. So here, if you see the average BMI value for for female and male treatment, it is 26.40. Okay. So this one for female and male treatment, the average BMI is 26.40. For female subject and the treatment group is placebo, the average BMI is 27.0. For male subject and main treatment, the average BMI is 22.69. Okay. But if you want to do in a very simple way, as I mentioned, if you just give define arm group, okay, and then if you give simply BMI, it will calculate the BMI across the arm group. So using this proc report, you can rename the variable, you can group the data, and also you can calculate the mean median also. Okay. So this is one example. Okay. Now, what we are going to do is we are going to see some clinical trial example. So I have five patient ID data, dummy data. So the first column is patient ID. So and what is the clinical trial site, and what is the gender, and what is the treatment, and what is the age, and what is the weight. Okay. So we have some baseline data, and okay. So baseline weight means at the start of the clinical trial, what is the weight, and after clinical trial treatment, after giving treatment, whether the weight is reduced or not. Okay, maybe 30 days after clinical trial or 30 days after taking clinical treatment, whether the weight is reduced or not. Okay, so baseline, the weight, this is the weight, and after giving treatment, what is the weight here? Okay, so we have two columns for weight. So here also some subjects are taking treatment A and some subjects are taking treatment B. And we have one more data called okay. So this is also similar. Okay. Now we will see. Okay. Let's take this example. Okay. So if you see here in baseline, we have the age, one table called age. Okay. So in this age, what is the average age and what is the average age for main treatment? What is the average age for placebo? Okay. So we are going to replicate the same in our data. So here, if, for this data, we are going to calculate the average age, mean age for treatment A and treatment B. Okay. So what I'm going to do is I'm going to use a column statement. And then I'm going to mention the variable name, treatment, and age. Okay, and then I'm going to use the define statement, and then I'm going to use. So here, if you see, I'm going to use the treatment, and then slash. I'm going to group the treatment variable, and then I'm going to use the define age. I'm going to use the option called analysis, and then I'm going to calculate mean for that. Okay. Okay. So here, if you see now, the average age for treatment A is 45, and average age for treatment B is 55. Okay. So if you don't give anything here, okay, it will simply take the define whatever you are mentioning in the column variable, it will display. Okay. But you can rename that. So you can put average age. So whatever you mention in the column name, it will display it here. Okay, treatment age. But if you don't want to display it, display the age, instead you can display average age. Okay. So what we are doing is we are calculating the mean. Okay. Now, if you see here in ct.gov example, clinicaltrial.gov example, the average age for the main treatment is 60.08. The average age for placebo is 60.73. In bracket, they have given standard deviation. Okay. So here also you can calculate standard deviation. So there is something called STD. So this will calculate the standard deviation. In bracket, you can mention standard deviation. Okay. Okay. Got it. Okay. I think there is some issue, I guess. But So, what you can do is we will see in next example how to create the third variable. But in ct.gov, if you, in the same way, they will calculate the average value. Okay, so this is the mean value of age by treatment. Okay, okay, okay. Manipulation. Okay. Okay, let's see the next example. Okay, now, okay, now we have calculated the age. Okay, similarly, we will calculate for the male, female also for gender. Okay, uh, so the so for gender instead of age you put sex and then mention defined and then treatment and slash mention group and then define. Say, so here we are not going to calculate the average. We are going to just check what is the count of participants. Okay. So instead of average, you can put sum count of male and female. Okay. Okay, so it is telling that the gender, the sex is the categorical variable, right? So for categorical variable, it is not possible to calculate the sum. Okay, so since this sex is the categorical variable, you create one variable name called count flag. Okay, Okay. So, okay. So, general, let me go to the data set. The problem is, so here if you see, if you want to check how many male and how many female, okay, that this gender is the numerical variable, categorical variable. Okay, so for that you can't do the analysis. Okay, mean or standard deviation. Okay, so what we are going to do is we are going to create one variable called count flag. So if there is male, it will tell one. If there is female, it will tell zero. Okay. So here in the previous data set, if you see, so there is one variable called count flag. Okay. So it will tell the patient ID one, and that is count one. Okay. And then for plus patient ID 2, that is one count. That means there is only one patient ID 2. Okay. And patient ID 3, one. Okay. So what we are going to do is using that, we are going to find how many male participants are there and how many female participants are there. Yes. Okay. Okay, so in the previous example, there is the example where you can have in the data set you will have something called count flag, and then in count flag in frog define how to use it. Okay. So mention the count flag here, and then in define count flag, put analysis and what is the count of that count flag. Okay. So this will give the table. Okay, how many subjects are in the female? How many subjects are there in female who is taking the main treatment? And how many subjects are there in the placebo who is taking the who is a female? And how many male subjects who is taking main treatment? How many main subjects who is taking placebo? Okay. So before doing analysis, the programmers will create one flagging variable. In that flagging variable, using that flagging variable, we can find how many participants, how many male taking main treatment, how many female taking the this one. Okay. Oh, okay. So this is for age and uh, uh, age and gender. Okay. There is one more thing called adverse events. Okay. So we will see how to create the adverse event table. Okay, I'm creating one variable called adverse event. So the first subject I'm mentioning headache, second subject nausea, third subject I'm putting adverse event as fever, fourth subject I'm putting chill, and final subject I'm putting rash. Okay, so I'm creating one adverse event variable also here. Okay. So we have adverse event variable. The first subject got rash, second subject nausea, third patient fever, fourth subject got adverse event chill, fifth subject also got rash. Okay. So in ct.gov, if you see, there is one adverse event table. Okay. So in that adverse event table, you can find in main group how many participants got high blood pressure, how many participants got palpitation. We have a table like that. Okay. So if you want to find a similar thing here, you can use two ways. Okay. One is proc freak, another is proc report. I will tell what is the difference. Okay. Let's use proc freak first. There are two variables. One is treatment. Use the keyword tables and then use the variable treatment star a. Okay. Okay. So this is one of the easiest way to create the table. Okay. Here you can see how in treatment A, how many participants got chill, how many participants got fever, how many participants got a nausea, how many participants got RAS. Okay. So, similarly, in treatment B, how many participants got chill, how many participants got fever, and all we have. Okay. If you want only so I'm telling no cumulative percentage and no percentage. Okay. So this is one way to create the adverse event table. Okay. That is very simplest way. Using table statement, mention both the variable name, treatment and adverse event. And then you, okay. So from this also you can create a table. Okay. Proc report. Using proc report also you can create a define. You mention a column and then you mention the variable name here. Sorry. Define treatment. Hmm. So using Proc Freak also, we are putting treatment in the vertical way, and across we are putting adverse events. Okay. Similarly, you can change instead that you can put AE. Uh, so here, if you see, now we got the same table like ct.gov. Here, if you see, columns, we are using both the variable adverse event and treatment. So since we need adverse event in the vertical way, we are using define and then we are putting a group. Okay. And then we need the treatment in the vertical way. So we are using group across here. And then this code will give the count of subjects here. Okay. So how many people got chill? How many people in treatment A got chill? How many people got in treatment B got chill? In fever, same. Nausea, same. So this is how the people in pharma company they generate the table for various things. Not only for clinicaltrial.gov website, they can do it for the regulatory submissions for various things. They use this report. Okay. So the important thing is you have to remember what is defined. Okay. And then the main thing you have to remember is you have to mention all the variable names in the column. And then if you want to display the variable, if you want to rename the variable, you can use the display word. Or if you want to group the data, you can use the group. And if you want to do some analysis, average or something, you can do that. And then and across, if you want the variable in the horizontal way, then you can use the keyword called across. Okay. So using this, the in pharma company, they generate various tables like adverse events, baseline table, disposition tables. They generate various tables like that. Okay. So you can, when you have a time, you can go to this website and you can check various clinical trial studies, and you can see how they generate. You can see their results of the clinical studies. Okay. So this is run by the U.S. government. Okay. Not U.S. government, FD, the NIH. It is the clinical registry website. Okay, so whichever study happens in US, that study has to be registered in this website. Okay. So the what the SAS programmers do is they will take the source data and then from the source data they use the proc report to generate the baseline table, adverse event table, and disposition table. Okay. Okay, so I think that's it from my side. If you have any questions, let me know. So I will give one assignment for this proc report. So after that, we will go to the advanced topic. If you have enrolled, you will be eligible to take that advanced course. Before that, you have any questions, let me know.
Sir, while you were writing the adverse event, the column itself, you had written first headache. It showed some error, then you changed it to rash. Why was that? Why didn't it take up headache or something? Yeah, the first one.
Okay, yeah, yeah. So I think the headache, the character is going more than eight, I guess. I think if the character is going more than eight, you have to mention it here, eight dot something. Okay. So since it is the rash is easiest one, I have mentioned just the character within eight. Okay. But if you want headache, you have to mention whenever the character is going more than eight, you have to mention it here. Okay, eight like that. So SAS will understand what is the character length of that. Maybe you can give maximum like 12, 13 also here. So, so what SAS will understand is it will read the data, symptoms name up to 13 character length. Okay. If you
Okay,
don't
okay.
give anything here, by default, it will read up to eight words. Okay, here nausea, it is up to the character limit eight. Fever, it is within eight. Chill, it is eight. I think for headache, it crossed eight. I think no. Headache, one minute, sorry. Okay, I think generally, I think initially it didn't come, but there is a thing that if the adverse event names are too long, it won't display. Okay, so that time you have to mention the what is the character length here. Okay, just for easy name, I have kept rash, but if it is within eight, you can give headache, nausea, fever, or something.
Okay, sir.
Okay. Okay. Other than that, if you have any questions, let me know. So what I recommend is when you are having a free time, go to this website, okay, and then check some clinical trials here. Okay, and then some trials will not have clinical trial results. You can filter down it here, okay, with results, and then each studies it will tell with result. If you click that, it will take you to that results. Okay, so if you see here one of the clinical trial here, I think it is done by Merck. So here also, if you see, there is only one group, treatment group, and then they have the baseline table. Okay. So the companies, what they do is the SAS programmers generally generate this kind of tables. Okay, adverse events and age. So for your assignment, what I will do is I will take some dummy data, and then I will ask you to generate this kind of table for ct.gov requirement. Okay, adverse events and this one. Previous recording sessions are available or not? Okay, Pooja, you have asked Anova. Okay, okay. I will send Pooja. I forgot. Sorry, sir. I will send. When I think last week there was no class, but I don't know. You are talking about the 1 week before, I guess. I think we have to check with Shamrati. I don't have
So
access to.
seven classes have been uploaded. I think this is the eighth class, right? Seven classes have been
Yes.
uploaded on YouTube.
Yeah, yeah. I haven't checked that. Shamriti used to upload that. I think correct. Seven classes uploaded. So when if you want to check that, please check. You have to check which. I don't know either Dr. Ajit. I think when you are asking about last week or before that, you are asking them. Okay. Last week classes didn't happen. So I think Shamriti has uploaded everything. Yeah. You are correct, Shamriti. Yes. So this is the final class. Shamriti will upload in some time. Okay. 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 If there is no other questions, we can close. If you have any questions, let me know. So, as part of this certificate, I will send one final project. So, people who have completed the project, only they will be able to get the certificate. So, at least try to complete that project in SAS, and so then you will be eligible to get the certificate for basic SAS. Okay. So thanks everyone. Don't hesitate to ping me if you have any questions. Thanks everyone.
Thank you, sir.
Thank you.